Okay, so welcome back. This is going to be part 8 of Negative Sequence Made Easier. This one is going to be over the GE369 relay. It's an older relay, but still I want to go over different ways of doing these current unbalanced equations. As I said, I'm going to go right here. The way that we're going to test is we're going to inject balanced angles, and we're going to change only one magnitude, and we're going to go above FLA on that one, and all the rest of them are going to stay at FLA. So that means that when we look at these two equations that they have right here, the one that we're going to use is this upper one because the average is going to be greater than FLA. All right, I still think it's really cool. GE puts this in here. It says a 1% voltage imbalance typically translates into a 6% current imbalance. I think that's wildly crazy. The math is just, it's neat with it. So as I said, we're going to use this upper equation right here. Again, if you use less than 30% of FLA, you defeat the whole thing. So I'd rather just make sure that we never get into not properly saturating the CTs or being too low of current. So let's just go above FLA and make it right. Just be careful that you don't hit short circuit or any other elements. Okay, so that's how we're going to do the test. And so I've already started out writing some things out here. So remember, the way that we're going to do this is all three are going to start at FLA at their respective angles, and B and C are going to stay where they are, but A is going to ramp up to some magnitude that we need to figure out. So what does that mean? We have this equation over here. Unbalanced is going to be some number in the relay, and this 100 right here just converts it into a to and from a percentage. That's all this is doing. So if you see in the relay it says 20, that's the default setting. Then in this equation we're going to do 0.2. Okay, so just remember that. I don't like to keep the 100 in there. So just remember that when you do the unbalance. This Imax, well, that's easy. Imax, we're raising A phase. So A phase is going to be above the average. It's going to be the max. And then what is average? Average is going to be this right here. And it's going to be IA plus IB plus IC. This absolute value sign right here that you see, the intent of this is to do two things. One, keep it always positive. We know that the max is always going to be greater, so we don't have to worry about that. But it also means only use magnitudes and do not use directions. So this is just magnitudes, IA plus IB plus IC. Well, we know IB and C are going to be FLA, so we can just substitute that in here, right? And then this is 2 FLA, so let's just distribute this 3 equally. So it's 1/3 IA, 2/3 FLA. Okay, so now we have this all sorted out. We could start substituting stuff in. So UB equals Imax minus IAV in absolute value IAV. I'm not going to do the 100%. You could just know that this is a percentage. Okay, I'm going to multiply both sides by IAV. So this is IAV times UB equals, and we know what the intent of this is. It's just phasors, magnitudes only, not directions, and intent to keep it above 0. So it's Imax minus IAV. Just make sure that we meet the intent of the absolute value sign. Let's substitute our IAV in. Our IAV is going to be UB times, and I'm just going to distribute this right now. So it's going to be 1/3 of UB, 1/3 IA, and then plus UB again, 2/3 FLA. All right, that's all I'm doing. I'm just distributing this UB to everything that I average equals. This should be IAV. Okay, and then this is going to be equals Imax, which is IA, minus everything in here, which is, I'll just go ahead and distribute the negative as well, which is 1/3 IA minus 2/3 FLA. So now let's combine like terms. We can definitely combine this, and let's move this over to the other side. And that's going to essentially be 2/3 IA minus UB 1/3 IA. And I'm going to take this and add it to the other side. So this will be 2/3 let me get this in line. 2/3 FLA plus UB, and this is equals, right? UB times 2/3 FLA. All right, I'm going to undistribute the 2/3 FLA from this, and then I'm going to take this and I'm going to take IA out of all of this. So we have IA, this is 2/3 minus 1/3 UB, okay? And then we have on the left side, it's 2/3 FLA, 1 plus UB. And this is an equals in the middle. Now we can just divide this on the other side. All right. I'm going to clear some room and rewrite this above. Now that we have that, we're just going to divide both sides by this 2/3 minus 1/3 UB. Then we'll simplify this shortly. So we'll divide both sides by this, and that'll get IA by itself. So IA equals 2/3. Let me get this over here. Divided by 2/3 minus 1/3 UB in parentheses. So now let's just simplify this a little bit. What I would like to do is just say this 2/3 is actually 2/3. And then we'll have FLA on the top, and then also 1 plus UB. And on the bottom, what we'll have is we could just take 1/3 out of both of these, and that'll leave us just 2 minus UB. Okay, so this is 1/3 times 2 minus UB. And this third and 3 cancel out. So now we're just left with IA equals 2FLA 1 plus UB divided by 2 minus UB. All right. So if the default setting is 20% in the relay, 20% of equals UB. Well, given this 100 right here, just convert it to 0.2 and substitute it in here. So this is 2FLA times 1 plus 0.2 divided by 2 minus 0.2, right? Which equals 2FLA times 1.2 divided by 1.8. And when you divide this out, what you get is IA with a default setting. If you raise just one phasor, IA should equal 2.4 divided by 1.8 times FLA, which is 1.33 FLA. Okay, so you could use this base equation right here to solve anything as long as you follow this format for your phasors. So hopefully this helps someone testing the GE369 relay.